Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial we're going to be finding the area of one petal of a petal curve. So this is polar area. Now before we get started, make sure to subscribe to the channel for notifications on more math tutorials. Alright, now let's take a look at our curve. Alright, so our example says find the area of one leaf of the petal curve r equals 3 sine of 3 theta. And of course, because this is a polar curve, we're going to be using polar area to solve this. This here is what our petal curve looks like. And here is our polar area formula. It says A, our polar area, is equal to the integral from alpha to beta of 1/2 times r squared d theta. In the example that we have, we're given r, so the only other information that we need at this point to integrate are our bounds. The best way to find our bounds is setting r equal to 0. That is 0 equals 3 sine of 3 theta. And it's actually easiest to simplify this down to 0 equals sine of 3 theta. Alright, so for this next part, I suggest that you all reference a unit circle. I'm going to break this down into two scenarios because there are two places on the unit circle where sine of theta equals 0. So scenario 1, sine of theta equals 0 when theta equals 0. And we're evaluating sine of 3 theta equals 0. And sine of 3 theta equals 0 when theta equals 0. So right now it looks like our lower bound will be 0. And then scenario 2, sine of theta equals 0 when theta equals pi. And again, I'm referencing a unit circle for this. Sine of theta equals 0 when theta equals pi. And that means that sine of 3 theta equals 0 when theta equals pi over 3. Alright, so our lower bound is 0 and our upper bound is pi over 3. So now that we finally have our bounds, we can integrate. So actually, before we integrate, we're going to do a little bit of work to the inside of the integral. First, let's take a look at this stuff being squared. 3 squared is 9, and then we have sine squared of 3 theta. And then we can push that 9 out. And at this point, let's just factor out the 9 over 2 to the outside of the integral altogether. So on the inside of the integral, that leaves us with sine squared of 3 theta d theta. Now at this point, we're going to use a trig identity. There's a trig identity that says cosine of 2 theta equals 1 minus 2 sine squared of theta. So this is pretty close to what we're looking for. On the inside of our integral, we just have sine squared of 3 theta. And so what we need to do is shift some things around here in our trig identity. And the goal is to get sine squared of theta by itself. So of course, to get sine squared of theta by itself, we subtract 1 from both sides and divide everything by -2. And that leaves us with sine squared of theta equals 1 minus cosine of 2 theta over 2. Now for us, we've got sine squared of 3 theta. So then we have 1 minus cosine of 6 theta, right? Because we multiplied our 3 times the 2 over 2 d theta. So you'll see we have another half here. So we'll factor that out as well to give us 9/4 on the outside of the integral, leaving us with 1 minus cosine of 6 theta d theta on the inside of the integral. And at this point, we can properly integrate. This is pretty manageable. We have 9 over 4, and the integral of 1 gives us theta, minus the integral of cosine of 6 theta, which gives us sine of 6 theta over 6. Plugging in our bounds, that leaves us with 9/4 times pi over 3. And this simplifies to our final answer, 3 pi over 4. And there you have it. We found the area of our petal. If this video was helpful for you, give it a thumbs up, like it, and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.